Hello and good morning, afternoon, whenever you're watching me. I hope you're having a good day. Today, we're going to look at lesson 1.6, constructions for parallel and perpendicular lines. Perpendicular is not too bad. We already learned how to make perpendicular bisectors. So we're going to actually use a pretty similar idea to construct a perpendicular line through a given point. Parallel will get a little bit tougher, but we can handle it. So I can construct a parallel line through a given point, and I can construct a perpendicular line through a given point. Those are our I can statements. So we're not worried about a perpendicular bisector. I just need to be perpendicular and go through a particular point. We had no new vocabulary to cover, so I'm not going to cover those in the video. So the first thing we did was we looked here and saw how things moved. So I noticed to go from, or you guys noticed, sorry, it was a class effort noticing it. Going from circle P to circle Q, we shifted right, we shifted up, we just kind of moved it into place. A to B was just moving it down. You guys, it took a little while to get that right word, but you were able to come up with the fact that this triangle DFE rotates to give me triangle JLK. And finally, we get that these two last lines, a little bit of a rotate, a little bit of a slide. So we've learned how to do a lot of stuff so far. So let's recap that. So we have learned how to create circles with a certain radius. Remember, you put the point at the center, then you set the compass to the radius and you spin it around, or some people like spin the paper around. Other people have been doing it online. And again, you're just using the circle tool. We've learned how to make line and line segments go through 2 points and just connecting dots. Create a regular hexagon. Remember, you can create that flower pattern by going around and then connect the dots. Equilateral triangle. Remember, we did 2 constructions for that. One was doing the flower pattern and instead connecting all the dots, you just do every other one. And the other, you can see on the video where we set after we did the 2 circles that look like a Venn diagram, like we do in a perpendicular bisector. What we then did was say, oh, where they cross, those are our 2 points. That's what we need to set our new radius to. We learned how to make a perpendicular bisector. So remember, to get a perpendicular bisector, you put it on one of the endpoints. You need to be more than halfway, and you draw a big arc. Then with the same arc setting, you go to the other endpoint, draw a big arc where they cross. If you draw that line, that gives you your perpendicular bisector, which can help us just draw a perpendicular line through a point. A perpendicular line through a point not given on the line, that's what we're going to do today, and a parallel line. So I'm going to speed things up. We're going to just have the steps right here. We're going to talk about the steps and see them in action here. So here we have this line AB with some point C. I need to go perpendicular to that. So what we're going to want to do is we want to draw a circle with a center at A and set the radius to AC. Then we flip it around to B. But unlike a perpendicular bisector where we have to keep it to the same setting, I actually now go B to C. So for this, we might get circles of 2 different sizes, and that's okay. It will look kind of like a perpendicular bisector, but what the different sizes make happen is it just makes a perpendicular happen. It does not force it to bisect, because if they're equal size, you're meeting in the middle. If they're unequal sizes, you're not going to be in the middle, but you will create that perpendicular. And then the last step will be to connect where the circles cross. So let's look at that in action on Desmos. So I already have the Desmos geometry tool up. Remember, that is desmos.com/ geometry. So I can make a random segment here. Actually, they had a line. So I'm going to make mine a line as well, not a segment. So let me undo that. So get a line. I'm going to leave and a point. So I'm going to label my points A over here. B also is on the line, and then label it, come on. And then C is up here. So I need to go A to C. That's my first move. That gives me this circle. Now I flip it around to point B. B is the center, and I go out to C. And as you can see, these are very uneven circles, but that's okay because I only care about where they cross. They cross at point C conveniently. And this point down here, if we want to give it a letter or a name, we can call that point D. And what I can do is connect C to D. And now that looks pretty good. But let's check the angle using the angle measure tool. So I can go C to where they cross to B, and indeed it is 90 degrees. Now, how do I know I did this right besides seeing that? Again, as I move point A, no matter how and where I move it to, I keep that right angle. Same with point B. Again, I can move it, I can bring it closer. Come on. There we go. It's a little choppy. Sorry about that. There we go. I can even move C all I want. As I move C again, you're seeing point C just keeps the right angle. So no matter how I go to try and move this, we maintain that right angle. So we did a correct perpendicular construction. So again, those were the steps. We drew a circle with a center at A and a radius of AC, then went center of B, radius of BC, and then we connected where the circles cross. Now the next construction, this one's a little trickier. And what we're going to do is I'm actually going to go through it twice because making a parallel line is a little bit tricky. So first thing we want to do is just make a perpendicular line through point C. Once we do that, we're going to create a circle with center C. The size of that circle does not matter. Then we want to create the perpendicular bisector of the diameter of that new circle. So what we realize is if I have a line down here, I go perpendicular to it, okay, that's good. If I go perpendicular again, it's almost like I'm making a square or rectangle. So those two right angles will then create parallel lines, because like we know in a square or rectangle, opposite sides are indeed parallel. So let's take a look at this in action. I do want to save this. So I'm going to save this as 1.6. This was just the perpendicular line. So I'm just going to change the title to say perpendicular lines. So sorry about that, adding a little bit of time to this video. Constructing, that's a G, and we don't need to worry about what pages this is with. Delete. And the link to this construction will be provided with the video. So it's going to be there with the upload. So you should see that below. So let's get a blank construction for this so we can do a parallel line. So I have my initial line down here. I have some random point C up here. So let's label these points A. Come on, label. B. And C. So what I'm going to do is start with that perpendicular line. So I go A to C, and I go B to C, and where they cross, I'm drawing a line through that. So that's all good so far. That was easy. Now, here's where life gets a little bit trickier. I'm going to go with C as my center and just make some random size circle. The size of this circle does not matter. So there we go. I'm going to label where these points cross as D and E here. Those are my next letters to use. So where the circle crosses, I want D to E to be the diameter of that circle. So there's D. Come on. There's E. E. There we go. So I know D to E is the diameter of the circle centered at C. The special part about being the diameter, I know C is the center. So if I make a perpendicular bisector set with between D and E, so if I do a perpendicular bisector for line segment DE, it will go through point C, the midpoint or center of the circle, and it will be perpendicular to line DE. And if DE is already perpendicular to AB, it will make it parallel. It will make the new line we create parallel to AB, since they're both perpendicular to the same thing. So I'm going to go D to E, and then I'm going to go E as a center to D. Now, some students saw this and said, oh, that looks like an I, like the eyes you see with. So yeah, it does. And that's a good way to help remember that visual, what a perpendicular bisector can look like. If you get that eye look, you got a perpendicular bisector. So I can draw the line that goes through them. And it does appear this line, which we're going to label FG, is parallel to AB. So we see this here. I can move point C around. And again, wherever I stop, it appears to be parallel to AB. I can even move A. And even though the slant changed, it still remains parallel. Again, moving point B down, did the same thing. It still remained parallel. I can move them back up. And I keep that parallel happen. I can't seem to get these lines to intersect. That means I correctly did the construction. So those are constructions. I just realized I'm making a video. You can rewind to watch this if you need to see that again. I don't think there's as much need to go over it twice like I did in class. So this was our parallel line construction. So let me get that named. And again, the link will be provided to you in the below on the video. So you should be able to see both these constructions. I will make sure that they are appropriately labeled right below the video so you can remember which one is which. So just as that synopsis here again, whoops, sorry, those are the wrong notes. Those are notes that we'll get to later. Sorry. Here are step one. We need to make a line perpendicular to point C. Then we create a circle with a center of C. Again, the size of that circle does not matter. Then we create the perpendicular bisector to the diameter of that new circle. And that will create parallel lines. So, to summarize what we know, we should know how to construct circles now. Line segments, regular hexagons inscribed in a circle, equilateral triangles inscribed in a circle, perpendicular bisectors, and perpendicular lines and parallel lines. So that is what we have for this lesson. Let me stop share. So guys, thank you for tuning in. I hope you got something out of this. Again, if you're having trouble with the construction, please make sure to ask questions in class, or you can go back and rewatch the video for some more help and support. Thank you guys, and please have a great day.